Greetings, everyone. As has already been said, we certainly miss bringing our telescopes out to the walkway tonight, but this is the best that we can do, so we will do it. I am going to put a little bit of text into the chat window that could be useful. It's just a little bit of reference, gives you a link for the Mid-Hudson Astronomical Association itself, and a few links for some of the stuff we're going to be talking about tonight. So feel free to reference that over there anytime that you'd like. Essentially, as we can't be presenting the sky to you in person tonight, we're going to use a little bit of software that's called Stellarium. This is free for PCs, and it's available for mobile devices at a small charge. It's really a lovely piece of software, highly accurate to the sky, and it basically allows us to use this kind of situation so that we don't have to drag our telescopes out, which we do love doing, but occasionally we get clouds like we have tonight, and other times we have this little unique situation where we just can't be there at all. Anyway, so with that, I have, as was mentioned, we have two of our membership going to be helping me out tonight. Eric is going to be driving Stellarium, so I'll ask Eric to go ahead and share his screen. And we'll be seeing an image that is from Stellarium. It's going to look a little bit familiar to most of you, looking south from the walkway. One of the cute things Stellarium does is allow us to put a background into it that can be pretty much anything. There is a link on that chat session of how you turn this up, but if you put Stellarium on your PC, you too could download the walkway and act like you're there. One of the other things we had hoped to do is move the time forward so that after this little talk was done, you could go out and have a look at the sky and actually see the things that we're going to talk about. Northeast weather has gotten in our way. I think we're going to be clouded out pretty much the whole time, so that's mostly out of luck. In any event, what we're going to do is look towards the west into the setting sun, and we're going to move time forward with Stellarium a little bit. Going to go ahead and watch the sunset because it actually doesn't hit the ground until about 8 p.m. It's going to be in the trees a little bit before that, but you'll start to see some of the brighter objects coming out. What we see right now is there, Eric set it back to the sunset time. There we go. Sorry, we're going to jump around a little tiny bit on this, but it's a little weirder with automation. In any case, as the sun goes down, we start to see some of the brighter objects in the sky. And I want to point out to you that on the bottom of the Stellarium screen, you'll see a little gray window that Eric's just popped up, and there's a set of numbers to the extreme right at the top. That is going to give us the date of the present view as well as the time. So you can see that we're looking at the 17th right now tonight, and we're looking a little ahead of time at about 2000, just 8 p.m. So we're about 20 minutes ahead of time on there from real time, and we're going to move that around. We're going to be moving forward a little bit in time as we go through this talk for reasons which will become obvious. Occasionally, if you run your mouse over the Zoom window, it will obscure that screen. Just don't move your mouse for a little bit and it'll come back if you're curious about what time and date we're looking at. All right, so for now, what we're going to do is speed things up just a little tiny bit until it gets just past sunset, and we're going to start seeing some of the brighter objects that come into the sky. Just the tiniest bit north of west, we're going to start seeing the brightest objects that are occurring to us right now. I think that I'm starting to see it just a little tiny bit up there on the screen. We'll let time move forward just a little bit further, and we start to see a bright object coming out of the twilight there. That is Venus. That is the closest planet to us, and it is bright to us because it has a massive atmosphere. It's very close to the sun, closer than we are, of course, but it has very reflective clouds, so it reflects a lot of sunlight. We're not going to zoom in to it tonight, but what we do with telescopes is we might take a good look at that. We'll actually see it in a crescent. It has phases just like the moon does. It's the only planet that's obviously able to give us phases like the moon. And that's because of its reflective atmosphere, but it's also because it's inside our orbit. So if we were to look in close to that, we would see a nice little crescent. It also means that as Venus gets closer to the sun, just like our moon, that's going to get thinner and thinner and thinner until it will be very hard to see. And then after a while, it's going to become our morning star instead of the evening star. So we're going to show the orbit of Venus now. And if you take a close look at where Venus is, you'll see a little arc that extends upward to the left at about a 45-degree angle. This is the path that Venus takes as viewed by us. When it's on this path at the right of the sun, it appears before the sun rises, and when it's to the left of the sun, it's appearing as it does now when the sun sets. It's our evening star. Early in June, it's going to pass in front of the sun. We won't be able to see it then. And then after about June 11, it will become the morning star, but you'll have to be up to about 5 in the morning to see it. Over time, it rises earlier and it appears higher in the sky, so you'll be able to see it a little bit later. But of course, it's going to be washed out by the sun when the sun comes up. All right, we're going to turn off the orbit of Venus, and at about 25 minutes past 8, we start to see some of the brighter stars as the sun gets dimmer and its influence on our atmosphere gradually decreases. Eric's moving time forward a little bit now, and there we go. We're starting to see, if you look at about 45 degrees up at an angle from Venus to the right, you'll start to see a tiny little dot there. That's one of our brighter stars, and that is Capella. If we looked to the left, past through west, we'll see another bright star start to come into play. That's Procyon, one of the stars in Canis Minor, the small dog. It's a very boring constellation, though, so we won't talk much about it. Just serves to see some of the brighter stars that come out as the sun sets. Now, what I want you to do is look down about halfway between Venus and the trees at about, a 30-degree angle. You start to see a small, weak dot that's coming out just above the trees. We can highlight that, and Stellarium is going to give it away. That is the planet Mercury. That is obviously the closest planet to the sun. It is much closer to the sun than Venus is, but it is much dimmer. The reason is it really doesn't have much of an atmosphere at all. Had it an atmosphere ever, the sun pretty much would have blown it away. So it's the closest to the sun, but it's very dim, and it never strays very far from the sun, so it's really hard to see. Now, in our sky, if you turn on the orbit, we see, just like we had the orbit for Venus, you can see that orbit is there, but it almost, at this point in time, doesn't quite reach where Venus is. So it's staying very close to the sun, which means that if you're using binoculars, or more particularly, if you're using a telescope and you're looking for, casting around looking for Mercury, you've got to be absolutely certain to not look anywhere close to the sun. That will ruin your day and your vision. But you can see it, and if you can see it ahead of time, it's best to point your telescope at what you can see rather than wander around looking for it. Very good way to get sunlight down the a telescope tube, and that's not a good thing. All right, we can turn off the orbit of Mercury. Um, Mercury is currently moving away from the sun from our perspective. What that means is it's come around the back of the sun from us, and it's climbing higher in the sky over time in its orbit. Over the next few days, it's going to get further from the sun. It'll rise in the evening sky a little bit higher each night until it gets as far out as it can go. This will make it even safer and easier to spot. At the same time, Venus has actually reached its furthest point in its orbit and is coming back in from our perspective. So it's going to be getting closer to the sun. And a little bit later, we're going to show you something that's quite interesting with those two. It'll happen a few days down the road, but we'll get to that. We'll return to that towards the end of the talk. All right, so what we're going to do now, I believe, is speed time up just a little bit. We want you to look to the left of Mercury and Venus, basically past west in towards the southwest, just a little bit past southwest. And then when the time gets to 8:50, let's see here, I think we're looking about now. Hey, look, what's that rising? Now, that's a bright object that we see quite often rising in the west. Wait a minute, we're looking towards the west. Don't things set in the west, not rise? Well, that's true for natural objects because of the rotation of the Earth. But this bright light is not a natural object. It's man-made. It's one of the most complicated machines that we have ever built. This is the International Space Station. And as a matter of fact, we're in a time right now where we get to see a lot of the International Space Station, but we'll cover that in a little bit. So ISS is also known as Zarya. That's the Russian word for sunrise. There are currently 3 people up there, 3 astronauts. They may be actually looking down onto the walkway at us, looking up at them from our homes. ISS is going to travel across the sky. It'll be visible for about 7 minutes tonight. It's a very good, very nice high pass. Unfortunately, we won't get to see it for real because of the clouds. As it passes through east, it's going to appear from our perspective to move slower, and kind of as it heads off towards the northeast, it's going to look like it almost stops in the sky until we just can't see it any longer. It's not really going any slower though. The thing orbits at about 17,000 miles per hour. It's just our perspective causing us to look like it's moving slowly. It's going to circle the Earth and appear again in about 90 minutes at about 10:27 p.m. and then 90 minutes again after that. And tonight, I think it's scheduled to show up about 6 times, some of which we might not see because it does require the sun to bounce off of it. And there's a time when the sun just isn't going to be exposed for a pass that it goes over. At 10:27 though, it's going to interestingly be aligned almost perfectly right at the west end of the walkway. So if you were standing in the middle of the walkway looking due west right off the end, it would rise right there. It's very cool to see. Okay, so on that pass at 10:30, we'd probably lose sight of it when it passed through the sun's shadow out of direct sunlight, and be about 6 minutes later. But this one's a long pass, completely in sunlight. After about 4 minutes of coming into view, ISS is passing through the largest constellation of the night sky. It's Hydra. We're going to show you the constellation lines. And that long, thin line with kind of a ball at the head is Hydra the snake. We can turn on images, and this is kind of what people thought that they saw in the sky with some of these stellar patterns. And Hydra, I believe, was a 7-headed snake. We've reduced it to 1, and that's fine by me. But it's the largest constellation in our night sky. It's just kind of interesting from that respect. Takes up over 90 degrees of the sky, if anybody's interested with that. It's absolutely huge compared to many of the others. The other ones, you can kind of compare their imagery here and see that they're considerably smaller. So while we're looking toward the southwest rather, we're going to show you what is called the plane of the ecliptic. This is not something we can normally see. However, this is a line along which you will find all of the planets and the asteroids if you've got a good telescope, the sun and the moon, and it's all there thanks to how our solar system was formed. So it's an imaginary line that we can extend into space and has objects that are related to the solar system along it. Some of them are kind of accidental, like our moon, really. But specifically, it comes from a Greek word. I'm going to mess this up. I hope not too badly. So those of you who speak Greek here, please forgive me. Eclipticus. Eclipticus means failed to appear. It's where we get the word eclipse and, of course, by extension, the ecliptic line. It's actually the line upon which the sun is appearing from our perspective on Earth to move. Of course, we're rotating. The sun, relativistically to us, is not moving, but it appears to move along this line because of the Earth's rotation. When the sun, the moon, and the Earth are lined up in a specific way along this path, the moon is between the Earth and the sun on the ecliptic. We have a solar eclipse. And when the Earth is between the moon and the sun, we have a lunar eclipse. The moon actually falls into our shadow. But the ecliptic has another particular significance to some. So if we pull out just a little tiny bit, you'll probably get where I'm headed right now. What we'll see is if you look along this line, you're going to start to see a few constellations which might be familiar to you. We have right down towards the western horizon, we have Gemini, the twins. A little bit further to the southwest, we have Cancer, a crab, Leo, the lion, Virgo, the virgin, Libra, the scales. These are the constellations of the Zodiac, and where why they're probably some of the most known. They lie along the path that the sun takes through the sky year after year. Every year they will go through these constellations at approximately the same time. Now, one thing that I had always wondered about is, let's take Taurus, for example. In astrology, as we say, the Taurus time frame is, I believe, April 20th through May 20th, and that covers where we are right now, May 17th, right? So the phrase is, the sun is in Taurus. It seems kind of strange to us because, well, you can't see Taurus during the daytime, so why would that phrase mean anything? So in Stellarium, we can remove the ground. So let's remove the ground now. And once we remove the ground, we're going to look along the line of the ecliptic. We're going to find the sun, and look what it's in. It's in Taurus. How about that? It's because that the folks who studied the sky knew where these constellations were going to be, and they knew that the sun would pass through them. That's where we get the significance of the astrological symbols and our time frames. So as we move through time, as we circle the sun will appear to move from Taurus into Gemini, into Cancer, into Leo, into Virgo, and so on throughout the whole year, all the way around the sky, 360 degrees. Just fascinating stuff. All righty. So let's see. This motion is also what's responsible for changing night skies throughout the year. Some of you may have noticed that you can only see Orion in certain times of the year, and you may have also known that Orion's belt, the three stars that form his belt, line up vertically sometimes of the year and so on, but that's not happening tonight. It's not happening at this point in the year. Well, what happens is as we rotate around the sun, the time of night when we can see Orion is going to change because the sun is on the opposite side of us, and we will get views of other constellations throughout the year, and just thanks to our rotation about the sun. So to complete our walk through the sky this evening, let's swing up around to the north, and we'll be looking up, almost straight up in the sky as we move to the north. This view tends to look a little bit weird. It's kind of like you were lying down on the walkway and looking up, but it's also a little fisheye effect. So it's just how the software gets portrayed to us. So there's north coming around at the bottom of the screen. And if we look up towards the top, we're going to see probably the most recognizable star group in the sky. It's the Big Dipper. Some people call it the Plow. There's many names for these constellations. Now, the Big Dipper is not actually a constellation. It is a grouping of stars that we refer to as an asterism. Eric has just turned on the asterism flag here. And what an asterism is a part of a large constellation. What that means is that the constellation we're speaking of, Ursa Major, or the Big Bear, is a larger grouping of stars, of which the Dipper is an asterism. So we can turn on the entire constellation group and see that there are more stars involved in the constellation of the Big Bear, there we go, than we see in just the Big Dipper. Interestingly enough, that's not true for the Little Dipper and some other constellations that we'll talk about later, but you can see pretty easily that the Big Bear is much more than the Dipper itself. So what we have here is a nice little convenience with the Big Dipper particularly, because as many people are aware, the last two stars in the far end of the bowl right there, pretty closely, if you follow those stars in a line and you just extend your line straight down, you're going to come to another star, which is not particularly bright, but it's reasonable. It's easily seen. It's the end of the Little Dipper, or Ursa Minor, and that is Polaris. We're lucky in the Northern Hemisphere because Polaris is very close to the Earth's axis of rotation. This means that if you were to extend a line through the south rotational pole at the north rotational pole and just keep going for a very, very long way, I frankly don't know how far Polaris is. I think I read it's only 1,000 light years or something. I can't remember. Quite a ways. It will pass very, very close to that star. So what that means is that from our reference point, all the objects in our night sky appear to rotate around Polaris. The axis of rotation is actually about 1/3 of 1 degree from our real axis of rotation. So Polaris makes a very tiny circle. As a reference point, the moon and the sun, for that matter, are both about 1/2 a degree. So it's a little tiny bit less than the width of the full moon, which isn't significant. So it makes a very good, reliable compass for those of us in the north to use. The south does have a similar thing, but it's almost impossible to see without a very good telescope. So they're less lucky than we are. So let's see, we can turn the constellations off and leave the asterisms on. And looking directly north and just above the horizon of the river, we see something that looks like a squashed W, almost on its side, but not quite. This is the easily identifiable constellation of Cassiopeia, the Queen. Represents the Queen on her throne. And as we look north and look at the pole star, as night progresses, everything we see here is going to appear to rotate anti-clockwise, which means that shortly Cassiopeia will look much more like a real W than it does now. Looks like it's standing up at this point, but eventually what it'll do is we'll run time around and we'll see that the sky rotates around the North Pole. There's a nice W of Cassiopeia, and it's just going to continue that way. We see that some of the constellations actually are high enough that they don't set. The Big Dipper doesn't actually set. They're close enough to Polaris to rotate around it, but to not drop below the horizon. Most of the other stars are going to appear to rise and set throughout the night. And by the way, those quick zips that we see through the screen every now and then are satellites of one sort or another. There's thousands of them up there. Before we complete the talk tonight, though, let's look back again at Venus and Mercury. Now we're going to do some fun things with time here. What we're going to do is look towards the west. Let's see if I can spot them coming around here. I haven't seen it yet. Oh, nice little nebula there. Okay, there's the sun coming down. So we have turned the atmosphere off, by the way, so that we can act as though it's dark all the time, even when the sun is up. So we can actually see the sun on the left side there about to set. And then those two bright dots just above it, that's Venus and Mercury. And I don't think I've done it yet, but I swore that sometime tonight, instead of saying Mercury, I was going to say Mars. So if I say Mars, just somebody hit me over the head. That's actually Mercury. We're not going to look at Mars today. It's on the other side of the sun. In any case, we'll see Venus and Mercury just setting in the west. Now we're going to pull a trick that we can do with Stellarium, and we're going to start moving forward a few days. We're going to actually move time forward. If we can get Venus and Mercury more towards the center here. There we go. Beautiful. And what we're going to do is move time forward. We should be on actually on the 18th now, since we went a day around. So we're going to jump forward to, there's Mars being, see there, Mercury being identified. So we're going to jump from Monday morning into Tuesday. Let's jump forward to Tuesday, there we go. And then we're going to jump another 24 hours. We're going to jump to Wednesday. And then we're going to jump to Thursday. And we might need to zoom in just a little bit there, Eric, to see that Mercury and Venus are very close together. They're about 1 degree apart. This is twice the width of the full moon. Remember, I said the full moon is about 1/2 of a degree. This is just not quite 1 full degree apart. So it's very, very close. This is something that we call a conjunction. Conjunctions occur when two objects are not actually physically close, but they appear to be close because of the relative position to us. We noted before that Venus is actually on the far side of the sun and Mercury is on the near side of the sun. So they're separated with quite a bit of distance here. But to us, they appear to almost be touching. This is going to be a really beautiful conjunction. If we have a break in some clouds by Thursday at roughly 8:50 at night, you should be able to go out and see this. Unfortunately, I don't think it's actually going to be visible, but we can hope. So that's very nice. And there's another interesting thing that happens at about 8:52 after we find this conjunction. Let's see if we can spot an old friend here. Are we out there, 8:52-ish coming in? It should be here any moment. There it comes, I believe, over the west. Yeah, it's just over there, just south of west, just the tiniest little bit, covered up by the Stellarium menu now, right between west and the flagpole. There's ISS again. Seems to be making its presence felt quite a bit this week. So much like we saw looking on Sunday night, here we are on Thursday, and here it is again. The orbit's a little bit different because the Earth is rotated beneath the ISS, and it appears to move from west to the north this time. Previously, at this evening, we saw earlier that it was going from the west through the south. It's always in the same orbit. It doesn't move. It's making a constant rotation around the Earth, but the Earth is moving underneath it, and that means that every time it goes over it, takes a slightly different path. We're not quite done with this, though, but this is kind of pretty still. It's neat. Conjunction of two planets and our most complicated piece of machinery flying right near them. But what we're going to do now is we're going to move forward 2 more days. We're going to move from Thursday. We're going to skip forward to Friday. There's Friday. See, the Venus and Mercury have separated a little bit. And then we're going to go into Saturday. And let's see what happens. I'm going to back up just a little bit in our time frame first, but only by a few minutes. And we're going to move soon here. I know it's in there somewhere. Or actually, Eric, is it there? And that's, or is that a smudge on my computer screen? Are we on the 23rd now? I've got my Stellarium screen covered up by the Zoom screen, so we might need to highlight our third object there. Yeah, there it is. Okay, it is in there. I thought it was a smudge on my screen, but yep, that is our moon. Now we have an interesting conjunction of 3 objects. We have Venus, Mercury, which is interestingly higher than Venus. That's a rare occurrence, but it does happen. And the moon. Now the moon, one reason I had a hard time seeing it, my little tiny monitor, is that it is just past what we call new. And we call a new moon one that is in a line between us and the sun. Obviously, if it had eclipsed the sun, it'd be something we would all know about it. But in this case, it's actually passed below the sun a little bit. There's reasons for that we won't go into tonight. But
Source.
it comes out of away from the sun. It's called a new moon, and it begins to wax at that point. So we're about 30 hours or so old at this point, which means that this moon is going to be a very, very thin crescent. If there's any possibility of seeing this, you definitely want to look. And now guess what? Who's making another appearance? Good old ISS. We've got a conjunction of 4 objects right there. Just gorgeous. I'm really hoping that we don't have clouds out this weekend, because I'd love to see that in person. And I would definitely love to take a look at that very, very, very thin moon and see how it looks on Saturday night. So that is pretty crazy. The moon obviously is very close to the horizon, as it is also close to the sun, so it's going to be very hard to catch. But oh man, I would love to see that in person. So we're going to end our walk through the sky roughly here. We've seen some stunning conjunctions.
What was the date and time for that last conjunction?
That last one,
Yes.
that is Saturday, which is the 23rd, and the time is roughly 8:55, I believe.
Thank you.
Is that what we have? Once again, I'll point out that Stellarium can be loaded on pretty much any PC at no cost. It can also be run directly from the web. And if you want to see some of these things and refresh yourself on exactly what they look like, you can run through it yourself pretty easily. Just make sure you put your location in so it knows where you are. Otherwise, it's liable to say you're in Albuquerque or England somewhere. But it's just lovely stuff for that. So we've seen these conjunctions, we've seen the relationship to the path that our sun takes in the sky to some astronomical history, and we've seen what seems like an awful lot of photobombing by the ISS. We've actually had to ignore quite a few passes. It's supposed to make 6 tonight that are reasonably visible, and then there's 4 more in Tuesday, I believe, and obviously a bunch on Saturday. The link in the chat session does have a couple of pages where you can go to find out information on when you can see the ISS, if you'd care to go out and look, as well as lots of other things. So before we take any questions, before I finish up, I just want to point out that 10 days from today, we mentioned there are 3 people on board ISS right now, but 10 days from today, on the 27th, the first humans are scheduled to be launched aboard the SpaceX Crew Dragon rocket. And this is the first time that the US has launched people since the end of the space shuttle program back in 2011. So if that launch does go off as planned, there's liable to be 2 more. It'll be a total of 5 people on board the ISS for a while. And once again, it's important for us because that's the first time that the United States is finally able to put people back into space. So with that, if anybody has any questions, I'd like to either hear them or see them. You may type them in the chat, or I guess if they can unmute. Somebody, Steve put 430 light years from Earth for Polaris, so good distance there. All righty. If there are no questions, I'll simply turn it back over to the walkway, and we've enjoyed it. Thank you.